Welcome back to the third video in this series. I haven't moved as far as I'd liked. I've had too many other commitments, but in this video I'll cover the installation of the radiators, the hot water cylinder, the manifold for the underfloor heating system, and share some of the lessons learned from this installation process. So this is the wood burner I purchased, a little more than what I wanted to pay for it, but hey ho. The real advantage of this one is that it has a pre-cut hole in the side to riddle the grate, which I'll remove and put the oil feed line into it. It's easy to return back to stock when I've finished. What I also got with the burner was this pump and the associated pipework. All of this will help with the plumbing for the system. As detailed in the second video, this is what I'm looking to install. So starting from the top and working down.
So this is the flue, the insulated flue coming through the polycarbonate roof. Just going to put the tin back. I had to take a wee bit out of the tin just so it wouldn't touch the rubber. It's close, but I just don't want it to rub it, cut it, go through it. Lots of silicone down there. Hopefully that'll be watertight, a flat roof, so it should be okay. So that's the water cylinder in. I've still got to put the top pipe in and the return line at the bottom, but I've done, and you won't be able to see it I don't think, the coil pipe. As you can just see the top one there and the bottom one. So that's ready to go. I'm just going through my box of plumbing bits just to see what's available. That I can use for the underfloor heating header. I've got 28 to 22 reducers. I managed to borrow a pipe bender. So really my next job now is to mount these radiators on the wall. That's the first radiator up. I've got to do the second one, and I've got to move all this lot and move the burner, and then we'll put the second one up. It's going to sit behind the wood burner, but I need the heat sink. That's the hose pipe connected to the bottom radiator, one of the two. So I've put in a temporary piece in there. We could use it for a pump if we need a pump. That's why I'm going to put the pump between the radiators. There's a drain valve for the boiler just down the bottom, whoops, there, and just skirting around this work of art down the bottom here. I think you can hear the gurgling. That's the that's the overflow pipe into the yellow bucket. We had a slight water leak there because I haven't put a clear plastic tube on top of the 1/2-inch copper, which I'm going to use as a sight glass. But I'm absolutely amazed that all the soldering I didn't get a leak yet. But there we are, there's the radiators, and just going to this madness down the bottom here. I've enjoyed making that. And this, I think I said earlier, between the two radiators, where are we? So between that joint, there's a loop going down and coming back up into there. That I'm going to use a potential place for a pump if I need it in the future. So up for the level gauge of the wee tank just there. I found a little blue stopper from a knitting needle tube. There we are. And that fits inside the copper pipe, but I want to stop it falling down, so I found this old filter, and I'm just going to cut a section out which I'll put at the top of the copper pipe to stop the blue float from coming down into the pipework. I pushed it in. I don't know if you can see it just at the top there. I put a slight dome in it so that it won't come out, but it'll go up, and the copper pipe will continue to push it up. So just pushing it down there gently, and I'll go and put it up at the top on the copper pipe. Filled up the water tank, and the overflow is working, and you can see the blue marker right in the middle. That's lifted up, so I've got a level gauge. So it's -1 outside, and I'm busy at the moment on cars, so I haven't had enough time to convert this over to waste oil. But this is the system. I've had it running for a couple of days now. The two radiators are fine. I needed the pump. I think I covered that earlier. The primary radiator, the first radiator, was getting lovely and hot, but then down at the bottom it's just a 15mm outlet, which is too small to allow the water to flow back into the second radiator and then back into the bottom of the wood burner. So the pump is needed. Now I bought a whole load of thermometers from eBay, good old eBay, and these cheap ones here, they look lovely, but they're totally inefficient. That one's showing 40 degrees on the return line, whereas the electronic one, I think you can see, is showing 73 degrees. And if I come over this way, I've got a whole load of other temperature gauges. I've got one on the exhaust flue, and I'll wait for that to come into focus. That's showing about 200, just under 200 degrees C on the flue. And then the water, this one here is the return, which is showing 60. These gauges are much better. And on the outlet, I've got one of those big gauges on the outlet there, and that's showing only, what's that, 50 degrees down at the bottom. And yet down at the bottom, this one's showing, where are we, 65 degrees. And up at the top of the output line, that's showing 65 degrees. Right, that's one half of the system. The other is the underfloor heating manifold that you can see in these photos here, and the video will give a bit more detail around the rest of the system. So let's look at the component parts. The heatsink, the radiator, the red valve in the middle there is an isolation valve for the radiator, the two manifolds. This is going up to the supply line, which is the line at the top, and the return line, the green pump, the circulating pump, the manifolds. I've put valves on each circuit. I've got 3 circuits in total. This is the line that goes up to the header tank, which I had to move quite a long way away because the hot water cylinder is quite high. The isolation valves and the mixer valve here with a blue cap, that's quite important. And really those are the component parts. So while this video is playing out, showing the rest of the system, this next video is Max, a good friend of mine, another classic car restorer. He's got an oil burner in his workshop, but he's got quite an important message.
The length is critical. There must be some place where you can get a measurement for the length of chimney you need for the fire to work efficiently. My chimney is probably just a wee bit short.
How long is your chimney?
About 20 feet. I would think another 5-10 feet and it would be absolutely, it would roar. And the fire would work really well. That can go red hot, but it's, especially if you're burning a bit of diesel in it. A slight mixture, just a drip feed of diesel and the oil.
Thanks, Max.
Lessons learned. I'll go through this very quickly because you can read the points really, but at the moment I think the flue is too short. I've got a restriction of the water jacket, which is affecting the airflow. It does take 30 minutes to get the water up to temperature in the header tank. The pump can be turned on after 15 minutes, but any sooner than that it'll affect the flue temperature and therefore it'll affect the fire. With the no underfloor heating, it does take 2 to 3 hours to get the shed up to temperature. The radiators, the 15mm feed is far too small, hence I need a pump. The cast iron radiators, yeah, they would be brilliant. They cost a little more, but they would encourage natural convection. The underfloor heating radiator, it is commissioned and it's working, but I need to put water into the underfloor heating tubes, which I didn't want to do just now because I was traveling away. Convection and circulation, it does flow, but too slowly. So under load, I've got a real concern that it'll boil over. If there is a power failure and the flame shuts down, I did test this, it does cope with it. The pump in the return line, yes, you need that. 15mm is just too small. But at the minimum setting, i.e. slow, it's more than adequate. So what's next? I do want to convert the wood burner over to waste oil. I'm going to have to extend the flue. There have been some comments that have come back in, which has been great. One of them is to find a step pump, and the other one is an H design in the tabs that's going into the burner. So thanks guys, I will try and incorporate those. I'm going to put a solenoid valve in the fuel line, so if there's a power failure, it'll cut off the fuel. Tubing into the burner, 10 mil, is it too small? 15 mil, somebody's passed comment that that was too small. Do I need to go to 20 mil? So I'll be checking those options. I will test the power failure and just make sure that the fire extinguishes itself. I do want to commission the underfloor heating. I do think that's the best way of keeping the heat in the floor in the shed overnight. The water heat store, I've got to be careful here. I may need antifreeze, but if the underfloor heating pump is left running, should that reduce the potential for freezing in the tubes? And basically it's then trial and error, see what the optimal oil flow is and report back on the progress, success or failure of the whole system.